Singleton design pattern is one of the gangs of 4 design pattern and falls under creational design pattern. Singleton design pattern is used for caching, creating driver objects, and logging objects. The main concept of singleton pattern is to create or return a single object of that class to save memory, because values or the settings of all the objects will be always same. Like every time we use new driver class, it should return me the old object instead of returning new object reference, as the driver class will never get changed. Let's see how can we implement a singleton class. So we have created a design pattern class, and inside main method we are creating two objects of singleton class. This class is empty as of now, and assign the objects to S1 and S2 respectively. When we run the main method, we can see that it created two objects. So in order to make it singleton, we need to make the constructor of that class inaccessible from other classes by making it private, and provide a static method which will return the class object. So here getInstance returns initialize singleton variable which is already initialized. And instead of new singleton, we will use singleton.getInstance, which will provide me the instance or the object of that class. We can't use new singleton because the constructor is not accessible from other class. And when we run it, we can see that both the objects are same. But this is not a good programming practice because the singleton class is already initialized, and for memory intensive object it can occupy unnecessary memory even before the object is being called for the first time. In order to avoid such scenario, we need to do lazy initialization. And to create the object when the first call is made. And for subsequent calls, we will just return the object that was created earlier. So we can see it works fine. But there is the issue with this type of if and else. Suppose in multi-threaded environment where thread 1 processes till line 5, that is the value is null, and then thread 2 comes and checks that lazy initialization value is null and creates an object, and then again thread 1 comes and rerun from line 6 and creates a new object. To overcome such scenario, we can make it thread safe by synchronizing the getInstance method. This will provide a thread lock while running the method, but this will slow down the process. Instead, we can use synchronized block and double check if the variable is null. And if the variable is not null, it will not go through the synchronized block. So if we rerun the program, we can see that both the objects are same. But we can break this type of singleton class. So in our next tutorial, we will see how to break singleton design pattern. That's all for this tutorial. Don't forget to hit like button, share and subscribe to CodeSpace. For any queries, write in the comment section below. Thanks for watching.